And so, as I mentioned, in an actual ranking cycle, due to irreversible phenomena, your efficiency is actually going to be lower than the efficiency if each unit operation operated reversibly. And so, in general, if you are dealing with a inefficient sort of ranking cycle, so if the turbine, pump, or compressors are inefficient, or if the problem tells you that the efficiency is less than 100%, then here is the strategy that you should take in order to solve the problem. The first thing you should do is when you're analyzing the turbine, pump, or in some cases, like compressors, such as when you're dealing with a refrigeration cycle, what you need to do is you need to do the analysis for the reversible version of the turbine, pump, or compressor, right? And so what I mean by that is you first assume S gen is equal to 0. And then in the case where S gen is equal to 0, you then calculate the enthalpy and entropies for this reversible case. And then using those values, you could calculate a hypothetical reversible shaft work. Okay. Once you have this hypothetical reversible shaft work, you then use the efficiency uh, given by the problem in order to calculate what the irreversible shaft work is, right? So the actual true work either produced or consumed by the unit operation. And then once you have that, you then redo your energy or entropy balance analysis using that irreversible shaft work. And that will allow you to find the true uh, enthalpy and entropy of the streams leaving the unit operation for that irreversible case. And then also you could use that to find the actual entropy generated by the process. Okay? And so this is a strategy that you should use for homework problems that are dealing with inefficient um, Rankine cycles or inefficient uh, refrigerators. Okay. One last thing that I want to mention um, about these types of problems has to do with the different definitions of efficiency. Okay. So a tiny aside. So when we talk about efficiency, basically what we mean in general is you take the ratio of whatever you want divided by what you have to pay. Okay, so that's just the general definition of efficiency. And depending on what you want, or depending on the unit operation that you're dealing with, your definition of efficiency will slightly change. Okay, and so for instance, if you're dealing with a turbine, your efficiency would be defined like this, where you have the efficiency of the turbine multiplied by the shaft work associated with the reversible case, right? So for that hypothetical reversible case, that product would give you the shaft work of the irreversible case, right? And so that's because with a turbine, you know, the irreversible case is the actual work that comes out of system, right? With a turbine, the whole idea is you're extracting work from the process. The work is leaving, okay? And so the irreversible case is the actual work that comes out of the system. While the reversible shaft work, that's just based on whatever the properties of the streams are. Clean that up. Based on streams going in and out, right? The reversible case doesn't account for any sort of entropy generated. And so consequently, when you're dealing with turbines, your efficiency is going to be your irreversible shaft work divided by the reversible shaft work. Okay? So that's the definition of the efficiency for a turbine. However, if you're dealing with a pump or a compressor, rather than producing work, You're actually putting work into the system for it to operate. And so the relationship with efficiency and the irreversible and reversible work is sort of flipped. So here you would have your compressor or pump efficiency multiplied by the irreversible shaft work, and that would give you the reversible. Okay. And so the idea is that with a pump or compressor, you're actually putting in work, right? And so this is what you put in, or essentially what you pay. And then this is what actually goes into changing the enthalpy of the working fluid. H of working fluid. So the steam or the refrigerant, depending on if you're dealing with a Rankine or a refrigeration cycle. And so consequently, for a compressor or pump, your efficiency would be the reversible shaft work divided by the irreversible shaft work. So it's a tricky subtlety. So you got to pay special attention to whether you're dealing with a turbine or a compressor, because that will determine how your efficiency is defined. And so these concepts, they're going to be relevant for Rankine cycles, refrigeration cycles, basically all of Homework 4.